So this function right here, this purple function, needs to be not an inverse, but a reciprocal of this function needs to be graphed. All right, so let's identify a few key points. Some of them will matter, some of them won't matter that much. Would you agree that this kind of seems like a key point up there? It's the high spot of the function. What's the name for that again? Well, assume it stops, by the way. So like this isn't an arrow that goes forever. This isn't an arrow that goes forever. So that's the local max. And it's also the what?
Absolute max.
Absolute max. Good. So 3, 5 seems like an important point. So everybody just note that it's 3, 5. All right. Next up, this spot, 6, 0. That seems important. Why? Because it's a 0. Also known as an x-intercept. And so is 0, 0. And so is -5, 0. And this end it's not a local max, but it just seems like an important point, -7, 4. And I would say the ends of your function are important points. Because where it ends, it doesn't just keep going. There's not arrows on the ends of these things, unless they put an arrow. All right. Now, there's some other points that you wouldn't think would be important, but actually are. And I'm going to tell you how to find those. Let's take this one right here. Would you agree the function pretty much goes through -1, -1?
Yeah.
I get that it's like a little bit off, but let's say that it goes through -1, -1. I want you to think about what 1 over f of x really means. You might be thinking, well, it's 1 over the function. Yeah, it is 1 over the function. But what's f of x? It's the function, and it's also the what? F of x is it the x? No, it's the
y.
It's the y. So what you do is you make up a new point for each of these points that has the same x and has 1 over the y. So let's take that first one we noted, the 3, 5. What would be the new point for that one? Say it.
3, 1 over 5.
3, 1/5. Yeah. I'm putting it right there. Everybody label it as 3, 1/5. You got how I got that? I just put 1 over the y value. You can do that on all of these points, but some of them are weird. Tell me one that would be weird. Yes?
Any x-intercept?
Yeah, all the x-intercepts are weird because you have, like for instance, let's look at this one, 6, 0. And what's weird about that? When you put 1 over the y value, you have 6, what's 1 over 0? No, it's not 0.
Undefined.
1 over 0 is undefined. That means that point can't really exist. So you put in an asymptote there. Your new graph will have some new points, and your new graph will have asymptotes. Anytime your function hits 0, you can't have 1 over 0. So when you're converting these points over, those points end up being asymptotes. And there's also an asymptote here. Because again, -5, 0 should turn into -5, 1 over 0, but that doesn't exist. All right, so we have asymptotes, and I'm going to start making these points, my new special points, I'm going to make them green. So here's a green point, 3, 1/5. So far, we know one point that's on the function, and we know some asymptotes. Can you give me any more? Well, how about everybody do this -7, 4? Cal, what's that going to turn into?
-7, 1/4.
Yep. Now let's graph it. -7, 1/4. It's down there, straight underneath the other one. Notice they share the same x value. Okay, now, do you get we have kind of a shortage of points? So, here's where you're going to get a whole bunch more easy ones. Everybody look at this -1, -1. What's the new point there? Yes?
There is no new points.
There is no new point because -1 comma -1 stays the same. You put 1 over the -1, it's the same. Okay? Do you get that means it's on my new function? It's one of the new points. One of the new points is the old point. And now, try to figure out why this point, even though it's not a nice lattice point, would also be one of my new points. Oscar, do you know why I just identified this guy?
Which one?
This one? This one? Why did I pick that one? I don't think you know yet. Somebody know? Why did I pick that one? You know?
Oh,
Oh, you figured out?
wait, no, sorry.
Okay, yes?
Is it anything with a y value of 1 or -1?
Yes. Because if its y value is 1, and you put 1 over it, do you get it stays exactly the same? So everybody put a dot here, and here, and here, and there's this one right here that I've tried to call out. Do you get, I just quadrupled like how many points I had? I got lots more points now. And frankly, I have plenty of points. I can get my answer now. I just have to know the rules about asymptotes. Do you know the rules about asymptotes? Do you know that you never cross the asymptotes? Okay. And do you know that you are supposed to get closer and closer to the asymptote but never touch it? Okay. If you follow those rules and one more, on a problem like this, you cannot touch the x-axis. You know why? Because if you touch the x-axis, what would the y value be? 0. Well, what happens if you have a y value of 0? Can you have 1 over that? You can't have that. You can't touch the x-axis. Here's another way to say it. Well, what if I just want to cross over the x-axis? Well, wouldn't you have to touch it to cross over it? So you can't cross over the x-axis, and you can't cross over the asymptotes. And you have to connect the dots. So let's zoom in on this one right here, this part. Do you get I can't touch the asymptotes, so I'm kind of framed in by that. It's like a fence line. It's like big, huge fences that you can't climb over, okay? And the x-axis, I can't touch that either. And I have to get closer and closer to the asymptotes. So there's only one thing I can do, and it goes like this. I'm going to go through from here, through here, and then I'm going to get closer and closer to the asymptotes, but never touch them. Closer and closer and never touch them. There. My function is the asymptotes plus that green line. That's my new function. How about over in here? Can you follow the rules? Get closer and closer, but never touch. And on the x-axis, that's not an asymptote. So you don't have to like hug right up next to the x-axis. You have to like get closer and closer and never touch. So I'm just going to kind of go like this. There. Now you might not like this area. You might be like, but how do you know to go, like, how far do you go away? Well, let's just get one more point then. Let's look at this point. Would you agree that point on the original function was pretty close to -3 comma -2? So then just make that as a backup point. Let's just make one extra point for that and say if -3 comma -2 was on the original, then what would be on the other? -3 comma a half. And look at that. I went right through it, just kind of like guessing. It would end up being up there. -3 comma -1/2. You know the mean way to make a kid do this? Would make you make like 30 points and then remake all the points with 1 over the y value. Do you get you'd have 30 dots, and any kid can connect 30 dots and then figure out the right answer? But the problem with that is it takes forever. If you follow my rules for this, you'll be able to do this super quick. I got to go through this point and get closer and closer and never touch. There. In fact, let me show you how quick you can do these. And the final answer again was the green loops there and the asymptotes. So imagine you had, excuse me, this function. Make it kind of like a half circle, except let's make it go like that too. So that's my f of x. And I'm only going to label the key points. We're going to say that's at 2, 0. That's at 0, 2. That's at negative 2, 0. And this, let's say it's at, well, if I'm going to kind of keep the symmetry thing going, it seems like about negative 4, comma, negative 2 maybe. Do you get that every one of those points on the original, you can make a point for it? You can change it to the same x, but the y is 1 over the y. Because again, what we're doing is 1 over the function. And f of x is also known as y. So you just take 1 over the y value. But here's my way of doing it. Watch how fast this is. I need an asymptote wherever it hits 0. I need to find the spots where it equals 1. That's where it's 1, and that's where it's 1, and that's where it's 1. And now I just need to follow the rules. I get closer and closer to the asymptotes and never touch them. And I can't go across the x-axis either. Maybe for this one point, the end point, it'd be smart to go, what's the new point? Negative 4, comma, negative a half. So I think that's about here. Okay, now I got 2 points. Yay, now I get closer and closer and never touch. That's it, I'm done. Do you get if I made you find like 9 more points? It would have been really painful to find them. And then you'd have to do 1 over their y values. And yeah, if you graph enough points, if you made enough dots, you would have been, it would have been really obvious to you exactly where you should go. But finding all of those dots would have been such a pain. And again, I think if I show you a few dots and a few asymptotes, you'll be able to be like, oh, I know exactly where to draw the line. If you get the rules, can't cross the asymptotes. Got to get closer and closer to the asymptotes, and you can't cross the x-axis, then this is pretty easy. So imagine you've done the hard work to find a few points and a few asymptotes. And there's one asymptote here. There's one asymptote here. There's a dot here. There's a dot here. And there's a dot there. That's all you'd need. Go ahead. What's the answer? It has to go through those dots and obey the rules about the asymptotes. I know where the answer is. Can you tell where the answer is? Cool. Go ahead and fill it in. And in a moment, I'm going to ask you to compare with the kid next to you. Make this picture. And then draw in where the line would have to go. See, once you get it to this point, with a couple of points and a couple of asymptotes, this part's easy. All right, I'm going to pause for a second while I pair people up. Okay, here's how you should have done it. You know it has to get closer and closer to the asymptote. So it has to go this way. In here, it's a little more vague on exactly what to do, but basically you're going to connect them. And then here, closer and closer to the asymptote. Now, how far it goes this way is kind of a judgment call, you know, like you can't tell because I didn't tell you. But it should be something like this. Raise your hand if yours looks something like that. Okay, good. Then, I think you're ready. Here's a problem. You're given this function, and it goes like, let's make it go like this. There, it looks like a big check mark kind of. And I'll identify the key points. That's negative, that's, sorry, 0, comma, -2. This spot here is going to be -4, comma 1. This spot here is going to be 4, comma 6. You should be able to graph the reciprocal of this. I'm going to pause for a second while you give it a shot. So we could have identified a whole bunch more points here and even kind of getting our best guess on what they were, and it wouldn't have been very fast. This will be fast. Instead, I'm going to just go through the asymptotes. Wherever it hits 0, there's an asymptote there. Asymptote, asymptote. And wherever it hits 1, I'm going to use green for that. This is the spot it hit 1. There must be another spot across from it where it hits 1. I know I didn't identify it, but you should have been able to use logic that it should be about halfway between here and 2, right? And then all those green dots, that's all I really need. Now I can follow the rules. Closer and closer to the asymptote. Closer and closer to the asymptote. And I'm going to on purpose make a mistake here. And kids do this all the time. Got almost all of it right, and I have to mark something wrong. You know why? You see the part I didn't do? I didn't do this part. There needs to be something over there. So do you get I need to give a safety point then? You remember that 4, 6? Cal, what would that turn into? 4,
4, comma 1/6.
4, comma 1/6. Very good. So that would be really smart because the end point, the last point, even if they don't identify it, I would try to figure out what the last point is and then just drop straight underneath it and say, well, then that'd be 4, comma 1/6, which might be down like there. Okay, I got to connect this and this, I guess. There. Now it's right. Raise your hand if you would have had it right. Okay, good. Then I think you're ready for the rest of this. To start with, here, I'd like you to graph 1 over x. Just graph 1 over x. We're not doing the reciprocal yet, just 1 over x. Do you remember what it even looks like? If you forgot this one, you've got a weakness. You're supposed to know that one. You got a little algebra issue if you've forgotten one of the parent functions. There. That's what 1 over x looks like. Now, it never touches 0. Do you get its reciprocal then? Won't have any asymptotes? Because this thing never touches 0 in the first place. Yes?
Doesn't this function have an asymptote at?
It does. That doesn't mean that there's going to be an asymptote on the other one. All right. So let's just take a few points that we know are important. Do you guys agree that 1, 1 and -1, -1 would be important points? Okay. And now, I don't have any asymptotes to work with. How in the heck am I going to do this? Then I'd make a few more points. Maybe we should make, like, that point. And maybe like that point. And maybe like that point. And maybe like that point. And identify what we think they are. Well, this was 1, 1. I think this one could be like, I don't know. Well, in fact, I could know what it is because I know the function. And let's say this is up 1, 2, 3, 4, 5. This would be 1/5, comma 5. Do you get I know that from this? If I'm 1/5, comma 5. Because if I put in a 1/5, if you understand that 1 over something makes it flip, you'll understand why 1/5, comma 5 works in there. And then let's say this is at 2, 3, 4, 5, 6, 7. Well, I made the, I kind of picked a dumb point. I shouldn't use that. I should use like a lattice point. How about we pick that spot? 1, 2, 3, 4, 5, 6. So this would be 6 comma 1/6. Because if I put in the x of 6, it gives me f of x, y equals 1/6. Getting how I did that? Now, I've got enough points here to start saying, okay, new point for this one? There is no new point for that one. New point for this one? 1/5 comma 1/5. New point for this one? 6 comma 6. Interesting. So it's like here and here and 1/5 comma 5 turns into 1/5 comma 1/5. Weird. It's a straight line. Whoa. If you didn't believe me, we could put in like maybe one more point. Like okay, I don't really buy that, Mr. Server. I'm gonna put in this point right here. Would you agree that that point would have to be 3 comma 1/3? Then do you get it would be 3 comma 3? See what's going on here? 6 comma 6, 3 comma 3, 1 comma 1, 1/5 comma 1/5. Whoa. Would it ever touch 0, 0?
No.
Nope. And I bet you're smart enough to go, well, and this would probably do the same thing. Yes?
Wouldn't the line start at 1, 1 always?
No. Because remember this point? 1/5 comma 5?
Oh,
That was that turned into 1/5 comma 1/5. All right, that was a weird one. Let's go back to the kind we do more often. We usually give you a picture like this. Okay, so let's take that, and I know it's kind of complicated, so for right now, skip the right side of the graph. Just ignore the right side of the graph. Just do the left side of the graph. It's a little too intense for one problem. So your original function is the red one. I'd start identifying some key points on it. I'd find it asymptotes that you'll need. Just doing the left side, compare what you think the answer is with the kid I paired you with. I'm going to pause for a second while you try this and check it with the kid next to you. See if you got the same thing. So here's how this one should have gone. Watch how fast it can go. Okay, so asymptote here, asymptote here, asymptote here, because those are all the zeros. Next, this is a key spot. I'm going to use yellow or green, sorry, for my key spots. Key spot, key spot, key spot, key spot. Oh, key spot. And then I just have to follow the rules. Don't touch the asymptotes, but get closer and closer. And there. Now, what if on that last one you were like, I wasn't sure where to go on that last one? On that last little leg, like right in there. What if you didn't know where to go? Well, pick a spot like there. Would you agree that that is -1/2 comma 1/2? Okay, so you pick that spot and then you say, well, what would that point be? Just that point gets changed to -1/2 comma, what's 1/1/2? This is really important. Some people don't know this. Do you get that 1/1/2 is 2? You didn't know that before. If you have a fraction and you put 1 over it, you flip it. Okay, so this would be 1/2 comma 2. And so then see how you would have known that there was another spot right there, and that would have helped you head in the right direction. Okay, so if you're ever stuck, just find a point, like I made up this one, -1/2 comma 1/2, and then transport that point to the new spot. All right. Now, I said this other side was too hard, but it isn't. It was just too hard for that moment. So now erase this out and like do this part. Way harder, but you can do it. Find the key spots, asymptotes. And remember, you can always make a safety point up, an extra point. Like, oh, I don't know where to go. Then name a new point on the red function and put 1 over its y. 15-minute warning. Mark and Geo absent.
Geo's here.
Oh. Geo, you can't just move on me. Are you ready? Tadros,
Yep.
how confident are you? Scale of 1 to 5.
5.
Nice. Okay. Tell me the first step.
So I highlighted the important points.
Okay.
So
Which would be like what?
all the ones that have a y value of 1 and -1.
All right, I like it. So did you note that 1 was like here?
Yes.
All right, good. And here, and here, and here, and here. And that's it for 1s. Okay, well now what?
And then the one at y -3.
Okay, where y is -3. Oh, this spot.
Yeah.
I agree, that's an important point. So that's gonna be 3 comma -3. All right,
And then there's asymptotes at 1.8.
well, at a minute, whatever this is, right?
Yeah.
Okay,
And then 4 and 6.
you're perfect so far.
And then I just started left to right. So it's on the farthest left point.
Yep.
It's going up towards the asymptote.
Very nice.
And then at the second point, it's going, or I guess first I'd move the 3 -3 to 3 -1/3.
Solid. Doing well so far.
And then I connected the 1/3 to the -1, 2, and then down, and then.
You mean like this?
Yeah,
Okay, I agree.
and then it's not connected to the point right under it.
Okay,
And then the -1, 3 is just down to the asymptote.
like that kinda?
Yeah.
You're right.
Um,
Now, some people are gonna be disturbed by this little gap here. And I hear you. And some people are gonna be disturbed because this technically, the way I drew it, would have a problem right there because it wouldn't pass a vertical line test. So, it is worthy of noting. So I'm gonna just say that there's just like it doesn't quite go to that spot, just so that we can kind of fake that it does pass the vertical line test here. And we'd have to clarify that. What should really have happened is on our original graph, we should have had made sure that this spot was clarified that it was maybe an empty spot right there. You know what I mean? Because otherwise, technically, our original graph wasn't a function. Because right here, it would have gone, a vertical line would have hit both spots, right? So that was just a small flaw in the problem. All right. And then, let's finish it up. I think I know where you would say to go. Tell me if I'm wrong. Is that what you said?
Yep.
All right, cool. There we go. That spot side got a little intense. Who in here, other than maybe one little thing, would have had it and got credit for it? All right, good. Okay. How in the heck are you graphing that? First of all, this is not a inverse. None of these were inverses. It's not even a reciprocal graph. It's just plain graph that. Do you know what that looks like? I don't know what that looks like. So how do you graph things when you don't know what they look like? XY chart. Who said that? You are so right. And honestly, I asked last hour and I only had one kid, even though I gave a lot of wait time, who remembered. You can make an XY chart. So I want you to all put 0 in, and 1, and 2, and then one more point that you picked that you might realize it would be a key point. So try putting in 0, see what you get. Try putting in 1, see what you get. Put in 2, see what you get. And then think of some other key point maybe you should check. I'm going to pause for a second and give that a try. Okay, if I put in 0, I get 1 over -3, or -1/3. If I put in 0, I hope you figured out put in 1. I hope you figured out that you end up with a 0 on the bottom, which would be the asymptote. So at 1, there's an asymptote. What if I put in a 2? If I put in a 2, I get 5 times 1/5. Huh. Who figured out that another key moment would be to put in -3? That was smart. Because -3 would also create an asymptote. If you didn't have it on your list, put it there. There's an asymptote at 1 and there's an asymptote at -3. Okay, I think that means that we're getting really close to the end of the hour. So I'm going to just say one more point. 0 comma -1/3 is like right there. And 2 comma 1/5 is like right there. I know this is crazy, but I have enough info right there to know that my graph must do this. Why can't it be the x-axis? Same as before of why it can't be the x-axis. 1 over something can't equal 0. I can't make the y be 0. So that means I can't touch the x-axis. And look at that. It's almost like one of those inverse. Sorry. Jeez, I did it at the very end. Reciprocal graphs. So what should you do for homework? You should do some reciprocal graphs. For sure. There are some in the homework. All right. Good luck. Have a great day.